So once you have a mesh from either segmenting a CT scan or just directly from a surface scan, it's unlikely that you'll be able to directly import it into whatever analysis you're planning on doing. Most meshes will need to be cleaned to varying degrees depending on what you're planning on doing with it. And there are many different softwares for working with meshes. As I discussed before, this technology was really originally developed for, or at the very least, has been greatly expanded by computer animations for things like movies and video games. So the two free softwares, of which I recommend getting both, are MeshLab and Blender. And these do two very different things. MeshLab is much more for adding pre-existing meshes, like the ones that are generated from scans, whereas Blender is more so on the computer animation side of thing for creating new meshes, but then also for doing rendering and textures and animations, that kind of thing. On the commercial side, I really like Geomagic Design. It is technically a computer-aided design software, but it has a lot of really great tools for fixing up scanned meshes and can even be used to surface scan directly. Maya and 3ds Max are both part of the same package of softwares called Autodesk that has a lot of other 3D softwares as well. And those two specifically are more so, again, on the computer animation side of things. And then Altair Hypermesh, I believe, is just another computer-aided design program. So when you look at a mesh, there's some different components to consider. Basically, as we talked about before, it's composed of these polygons called faces, but then those are connected by edges, and then at each intersection there is a vertex. And you need all of these components for the mesh to be correctly defined. The other component to keep in mind is what's called the normals. A normal is basically just which side of the plane or the face the computer program is going to render on. So this isn't just important for things like rendering, but also if you're planning on doing any sort of collision kind of analysis with your mesh. It will also tell the collider where to go. If you're looking at things like derelict normal energy for teeth, the normal will need to be pointing out for that analysis, normal to the direction of the plane. So the image I have here can kind of give you an idea of what it looks like, since it's kind of a hard concept to see directly. This was taken in Geomagic, and this is a surface scan of a lumbar vertebrae that still has some holes in it because it's very difficult to get the points of the lumbar when doing the full scan. So the normal side of the faces are colored blue, and then the way Geomagic renders reverse normals is it chooses the opposite color to render the reverse normals, in this case orange. So you can actually see there's a hole in the mesh right here, and you're looking at the opposite side, the reverse normals of these faces. You can also get that impression where you're looking through the hole in the mesh right here, and you can see, again, the reverse normals right here. The reason I show this in Geomagic and not one of the free softwares is because how reverse normals are rendered will vary dependent on software, and that's why it's so important to make sure you are getting your normals facing correctly. So Blender will just render them the same as normals, but then a program like Slicer actually will only render the normals, and it will just look like you're looking into nothing with the reverse normals. And so it's really important to keep that in mind when you're going through and cleaning your meshes. So a good clean mesh will look like what I just showed, but oftentimes, especially if you're working from a mesh generated from a scan, you can get all sorts of little geometry errors. You can get isolated components, just little vertices or edges or faces floating off away from the mesh that you'll want to get rid of. You could get edges hanging off, so it may still be technically attached to the mesh, but it's not connected to any faces. You can get disconnected edges where it looks to your eye like it's just one edge connecting two faces, but there's actually a disconnect there. And then, of course, a flipped normal where one face is facing the wrong direction. And these are especially important for when you need what's called a watertight mesh, which means it has no holes in it, and all of the normals are facing outward, and that's the kind of thing you need for, like, say, 3D printing. Once you've repaired geometry, there's still even extra steps you might want to take. So things like remeshing, where maybe you have a technically clean mesh, but a lot of the faces are different sizes. So if I bring in this scan example here, you can see there doesn't appear to really be any holes per se in this, but some of these faces are a good size, and then some of them are extremely small to the point where it might start causing some geometry errors. And in that case, we could uniformly remesh so that everything is the same size. Another option is decimation, which cuts down the number of faces while preserving the shape. And that can be really important if you're doing some sort of analysis that requires each mesh to have the same number of faces. Like, our tooth analyses require that each tooth has the same number of faces to get an accurate comparison of things like orientation, patch count, which faces are facing different ways. And then there's just smoothing, which is, depending on what your mesh looks like, could just almost be an aesthetic thing if it's something you want to 3D print, or it could actually be important if you've got like kind of weird bumps from scan artifacts that you want to smooth over. So next we'll hop into Mesh Lab and Blender and take a look at how you can actually do some of this stuff.